There's a reason Amish farms have grown food on the same land for over 200 years without it ever wearing out. No synthetic fertilizer, no soil testing kits, just a rotation pattern passed down through generations that modern agriculture is only now circling back to. By the end of this video, you'll know exactly how it works and how to use a version of it in your own backyard. Picture this. You plant tomatoes in the same raised bed 3 years running. Year 1, they're gorgeous, heavy with fruit, exactly what you pictured when you built that bed. Year 2, they're a little smaller, a little slower to ripen, and you tell yourself it's just the weather. Year 3, they're yellowing, stunted, and covered in the same blight that showed up last summer too, except now it's worse. You add fertilizer. It helps for a few weeks, then the plants slide right back into the same pattern. This is the quiet frustration of so many home gardeners, spending money on a symptom every spring while the actual cause sits untouched in the dirt season after season. Soil isn't a static container that just needs topping off whenever it runs low. It's a living system full of microbial life, fungal networks, and a nutrient balance that shifts constantly depending on what's growing in it. Every crop you grow pulls specific nutrients out and leaves specific residues behind. Plant the same thing in the same spot repeatedly, and you're not just depleting nutrients, you're also building up the exact pests and diseases that target that plant year after year in soil where they're already comfortable and waiting. Gardeners rarely connect these dots because the symptoms show up slowly. A bed doesn't fail all at once. It erodes a little each season until one year the decline is impossible to ignore. And by then, most people assume the answer is a stronger product rather than a different approach entirely. Amish farms deal with this same biological reality, except they've never had the option of masking it with a bag of synthetic fertilizer. Their communities largely avoid chemical inputs, relying instead on composted manure and deliberate crop sequencing to keep soil balanced through natural means. That constraint forced a level of precision most modern farms never had to develop because there was no shortcut waiting in a delivery truck. Here's the part that surprises people. The Amish aren't guessing, and they never were. Their crop sequencing follows a deliberate logic refined over generations of trial and observation that still holds up under close scrutiny 2 centuries later. This isn't nostalgia dressed up as farming advice. It's a working system that simply never needed replacing. If soil health like this actually interests you, hit subscribe so you don't miss the next one. Most people assume synthetic fertilizer is just a faster version of what manure and rotation do. It isn't. Fertilizer feeds the plant directly, delivering a hit of nitrogen, phosphorus, or potassium exactly when the plant needs it. But it does almost nothing for the soil's actual structure, its microbial life, or its long-term capacity to hold and cycle nutrients on its own. Industrial farming leans heavily on continuous cropping, the same cash crop, same field year after year, and simply replaces whatever the soil loses with a purchased input. It works for a while and the yield numbers look fine on paper, but it treats soil like a shelf to restock rather than a system to sustain, and shelves eventually run empty no matter how often you refill them. Iowa State University's crop extension program has tracked exactly this, following how continuous single crop cycles affect nitrogen levels, soil tilth, and physical soil properties over time. Fields locked into the same crop year after year gradually lose the resilience that rotation-based systems hold on to, even when fertilizer inputs stay exactly the same. There's a chemistry reason this matters beyond just nutrients. Soil pH drifts over time under continuous cropping, and so does the balance of microorganisms living in it. When the same roots occupy that soil year after year, the microbial community narrows instead of staying diverse, and a narrow microbial community is fragile, more vulnerable to disease, and less able to help plants reach nutrients that are technically present, but locked in forms roots can't use. The Amish built around a different principle instead. Every crop in the sequence has a job. Some feed the soil directly, some feed the crop that follows them, some do nothing but rest the ground and let it recover, restoring microbial diversity along with nutrient balance. Nothing in the rotation exists purely for yield. Each piece supports the piece that comes after it. Farmers today miss this pattern constantly. It isn't that the Amish avoid chemicals out of some strict religious restriction limiting their options. Their whole system was engineered deliberately and over generations, so chemicals were never necessary in the first place. Once you see the full sequence laid out, the absence of fertilizer stops looking like sacrifice and starts looking like sound design. Here's the actual sequence, and it's simpler than most people expect once it's broken down. A typical rotation runs corn first, followed by a small grain like wheat or oats with a legume seeded underneath it, then 1 to 2 years of hay and pasture before the whole cycle returns to corn again. Each stage earns its place in the sequence. Corn is a heavy feeder. It pulls hard on soil nitrogen and organic matter, leaving the ground noticeably depleted by harvest. The small grain that follows asks far less of the soil, giving it breathing room. while the legume growing underneath it, usually red clover, quietly fixes atmospheric nitrogen back into the ground through a symbiotic relationship with bacteria living in its root nodules. Then comes the part most home gardeners skip entirely, the rest phase. 1 to 2 full years of hay and pasture lets the ground rebuild organic matter, restructure itself around deep perennial root systems that aren't being harvested, and recover fully without any crop demanding anything from it. By the time corn returns to that field, the soil isn't depleted at all. It's been quietly restocked by 3 separate mechanisms working together in sequence. The USDA lays this exact logic out in its own guidance on cover crops and rotation, noting that rotating crops raises nutrient and organic matter levels in soil while disrupting the pest life cycles that build up under repeated single crop planting year after year. Manure plays a supporting role in every single stage too. Nearly every Amish farm runs livestock, dairy cows, horses, sometimes hogs or chickens, and that manure gets composted carefully and returned to the fields on a deliberate schedule, timed, measured, and rotated right alongside the crops themselves rather than dumped indiscriminately. A mature dairy operation can produce enough composted manure to maintain fertility across an entire farm without buying a single external input. The timing of application matters almost as much as the manure itself. Spreading it before the hay and pasture phase means those nutrients get absorbed slowly by deep-rooted perennials over a year or two, rather than flooding the soil all at once the way a synthetic application does. That slow release is part of why the system holds up decade after decade instead of degrading. You don't need 5 acres or a team of draft horses to put any of this to use. Even a modest backyard garden can follow the same underlying logic, just compressed into raised beds or divided garden sections instead of open fields stretching to the horizon. Start by grouping your plants into 3 rough categories. Heavy feeders include tomatoes, corn, squash, and most fruiting vegetables. Light feeders and soil builders include beans, peas, and clover, which give back more than they take. Rest crops can simply be a cover crop like winter rye or oats, left to grow through the off-season and tilled back into the soil before it goes to seed. Rotate a section of your garden through all 3 roles across a few seasons instead of replanting the same crop family in the same spot out of habit. If you grew tomatoes in one bed this year, follow with beans or peas there next season to rebuild nitrogen, then let that same section rest under a cover crop the year after that before cycling back to a heavy feeder again. A common mistake gardeners make is rotating crop names without actually rotating crop families. Tomatoes, peppers, and eggplant are all nightshades and pull on the soil in nearly identical ways, attracting nearly identical pests, so swapping one for another isn't really rotating anything at all. Track families, not just individual vegetable names, when you're planning next season's beds. Squash, cucumbers, and melons belong to their own family and behave the same way toward each other. Corn stands alone as a heavy nitrogen user, with almost no overlap with the nightshade or squash groups, which makes it a useful bridge crop between 2 heavy feeders if you need one. Keeping a simple written map of which family grew where, even just a rough sketch taped inside a shed door, saves you from repeating a mistake you won't remember making 3 years from now. This kind of cycle breaks pest and disease buildup at the source, builds organic matter steadily during the rest phase, and spreads nutrient demand across completely different plant types instead of hammering the exact same nutrients out of the same patch every single season. Give it 2 full cycles before judging the results for yourself. Soil rebuilds gradually, not overnight, and the biggest gains usually show up in year 2 and year 3, once organic matter has actually had real time to accumulate and the microbial community has re-established itself. Resist the urge to judge the first season against what a bag of fertilizer would have delivered, since you're comparing 2 entirely different timelines. One trick that speeds things up: interplant your rest phase cover crop with a mix rather than a single species. A blend of clover and winter rye covers more ground biologically than either one alone, since the clover fixes nitrogen while the rye's fibrous roots hold soil structure together and suppress weeds at the same time. Small mixes like this compress some of the benefit of a full year of rest into a shorter window, which matters if you're working with limited bed space and can't dedicate an entire section to rest for a full season. Set this rotation-based approach next to a bag of synthetic fertilizer, and the comparison gets uncomfortable fast. Fertilizer costs money every single season, indefinitely, with no endpoint in sight. Rotation costs nothing but planning ahead and a little patience while the system does its work quietly underground. Fertilizer feeds the current crop and leaves the underlying soil structure completely untouched. Rotation feeds the soil itself, which means every future crop grown in that spot benefits, not just the one you fed this particular year. One approach rents fertility one season at a time. The other actually builds it layer by layer into something durable. There's also the pest angle. Most gardeners never connect back to their fertilizer routine at all. Continuous planting of the same crop doesn't just deplete soil of nutrients, it creates a stable, comfortable home for the exact pests and diseases that specifically target that plant. Rotation breaks that cycle entirely, simply by removing the host plant from that soil for a season or two and starving the problem out. None of this means fertilizer is inherently bad, or that you need to abandon it completely overnight, but leaning on rotation first and treating fertilizer as a rare supplement rather than a yearly requirement is closer to how soil actually wants to function on its own. It's slower to show results. It's also the version that keeps working in year 20, not just year 1, long after a fertilizer-only approach starts to plateau. There's a cost angle worth sitting with too. A single season of synthetic fertilizer for a modest backyard garden can run you $30 to $50, sometimes more depending on the size of the beds and how depleted the soil already is. Multiply that across 10 or 20 years and you've spent hundreds of dollars propping up soil that never actually got healthier, just kept afloat. A packet of cover crop seed costs a few dollars and can be reused season after season once you're saving your own seed, which means this approach gets cheaper over time instead of more expensive. Think of your garden less like a machine you refuel and more like a relationship you tend. The old rhythm behind this asks for patience up front and pays it back for decades. A bag of fertilizer asks for nothing up front and quietly costs you every year after. That's the real shift here. Not a new product to buy, but a different question to ask before you plant anything. What did this bed grow last year, and what does it need to recover from that? Answer that honestly, and the rest of the plan mostly writes itself. If this changed how you look at your own backyard, there's another forgotten method worth knowing just as well, and it's coming up right after this. Modern families, ancient solutions, zero chemicals,